What is an electric cell? Electric cell is a device which can convert chemical energy into electrical energy. There are few examples of electric cells. First one, dry cell. I had already explained about dry cell in the previous video. Second one, lead acid cell. Third one, nickel cadmium cell. Fourth one, lithium ion cell. Now we are studying from lead acid cell. Now lead acid cell, how it is made, that I am showing you. This is a container. In that an electrolyte will be there. That electrolyte is sulfuric acid solution. The electrolyte, this is the sulfuric acid solution. We can say that this is the electrolyte. In that there will be two electrodes. One is the positive electrode, one is the negative electrode. Positive electrode is known as anode, negative electrode is known as cathode. Negative electrode is the cathode. Positive electrode is the anode. Here, this negative electrode is the lead. Lead rod. PB means a lead rod. Now here positive, or we can say that anode will be lead dioxide, PbO2, lead dioxide rod. Lead dioxide rod. Now these two rods we have to connect with a wire, and if we are joining the ends of the wire with a voltmeter or bulb, if we are connecting here bulb will glow. If we are connecting a voltmeter, then its needle will deflect. So here now I am making one bulb. You can find that bulb will glow. So this is the lead acid cell. The speciality of lead acid cell, its electrolyte is in liquid condition. We studied about dry cell. Its electrolyte is in the condition of a wet solid condition it is there. it is not like this sulfuric acid. Sulfuric acid is in liquid condition, but this is almost, we can say, solid or semi-solid condition in the dry cell. Now this lead acid cell can produce the potential difference of 2 volt. It can produce the potential difference of 2 volt. In case of dry cell, it can produce potential difference of 1.5 volt. Now we are studying about other electric cell, that is nickel cadmium cell. Now diagram almost same will be there, only the chemicals as well as electrodes name will be different. So structure this diagram as that only I am keeping, electrodes name I am changing. Now we are studying about nickel cadmium cell. Nickel cadmium cell, in that this cathode or negative electrode will be cadmium rod. Now positive electrode or anode will be nickel hydroxide. Nickel hydroxide. Nickel hydroxide rod. So in case of nickel cadmium cell, 2 rods are using. First rod, that means we can say that cathode is cadmium rod, anode is nickel hydroxide rod, and the electrolyte filled inside this container, that is potassium hydroxide solution, we can say potassium hydroxide solution. That means potassium hydroxide plus distilled water. Same way, here now rods are kept. This is anode, anode made with the help of nickel hydroxide, cathode made with the help of cadmium rod, both of them inserted or put inside the electrolyte potassium hydroxide solution. Because of the chemical reaction of these chemicals, there will be the flow of current from positive terminal to the negative terminal, again from negative terminal to positive terminal, like that way flow of current will take place. As a result of it, you can find that bulb will glow. Now we are studying about lithium ion cell. In case of lithium ion cell, again same diagram only I am showing you, chemicals I am changing. Here we are studying about lithium ion cell, how it is making. So here we can say that this negative electrode will be lithium rod. Negative electrode will be lithium rod. At the same time, here positive electrode, or we can say anode, is made with the help of graphite, or we can say carbon rod. And the electrolyte is made with the help of salts of any type of lithium salt, maybe chloride or some other type of salt. So we can say they didn't express here, they didn't say here. So we can write here salt of lithium. There are different types of salt. So any type of salt they are using here as the electrolyte in the production of lithium ion electric cell. Now here, this is the lithium ion cell. In lithium ion cell, lithium rod is taken as cathode, graphite rod taken as anode, then salt of lithium taken as electrolyte. Here again you can find that as a result of the chemical reaction between the chemicals which are present inside this arrangement, there will be the flow of current from positive terminal to the negative terminal, and like that way this process keep on occurring. Now in comparison with the dry cell to the other electric cells, dry cell, as I told you yesterday, once it start to use, or once a dry cell connect with a device, then few days it will work. We can say that approximately 1 month it may work. Afterwards, the chemical reaction or its capacity to convert chemical energy to electrical energy stops. The device stops, or we can say the cell will stop functioning. But at the same time, as we studied now, 3 different types of, leaving this dry cell, other 3 electric cells. These lead acid cell, nickel cadmium cell, as well as lithium ion cell, these all things we can charge it again and again. So once its a charge will get over, again we can charge it or charge them. So we can say that here there is no problem of buying new cells. If we are using dry cell, then we need to replace them with a new dry cell. But at the same time, if we are using such a type of cells, we can recharge them and we can use them again and again. In various devices, we can use all these types of cells. Now we can say that lead acid cell is using in trucks, then rickshaws, cars, as well as bikes. There means light producing with the help of the chemical reaction of lead acid cell. As a result of it, chemical energy converts to electrical energy. Now each cell of lead acid cell can produce 2 voltage of or 2 volts of current. Now we had studied about dry cell. It can produce 1.5 volt of potential difference. Now in case of nickel cadmium cell, it can produce 1.2 volt of potential difference. Now similarly, in case of lithium ion cell, it can produce 3.6 volt of potential difference. So as we had studied now, once again I'll repeat. Dry cell can produce from one cell 1.5 volt of potential difference. In case of lead acid cell can produce 2 volt potential difference from one cell. Now nickel cadmium cell can produce 1.2 volt potential difference from one cell. Lithium ion cell can produce 3.6 volt potential difference from one cell. Now uses of dry cell already we had studied. Now lead acid cell can use in rickshaws, cars, trucks, bikes, etc. Then nickel cadmium cell can use in mobiles. Different types of mobiles its use is coming. And lithium ion cell can use in laptops as well as various types of smartphones or mobiles, you can say, or smartphones. Now we will study about what is symbol circuit. Here in symbol circuit there is a necessity of a conductor, a bulb, as well as a cell. Now we'll see here. Even we can use a key. Key means a switch. This is the conductor. Conductor means a wire. Now here this place I am using one cell, one big line as well as one small line. Big line shows that positive electrode or anode. Small line shows that cathode. Big line, that is the anode, positive electrode, then small line, that is the cathode. Now here I am connecting one bulb, now here I am connecting the key. Now as and when we switch on, key closed, it's meaning key on. I am connecting both of them in joint condition. So we can say that now it is the key is in closed condition. That means the key is in on condition. Switch is on. You can find that the bulb started to glow. So this is the example of symbol circuit. This is the key connection, switch connection, switch on as well as switch off possible. Now here this is the conductor. From positive terminal to the negative terminal, the flow of electric current will take place. So this is an example of symbol circuit. Now how we can be able to connect a number of cells in a circuit? For that here I am drawing one cell, normal cell I am drawing. Now this thing is connecting with the other cell. Again this is connecting with the other cell. Same way, number of cells, if we are connecting one after other, we can be able to produce large, here this one we are connecting with this, and this one again connecting. The connection, how it should be, positive terminal should connect with the negative terminal of the cell. This is the negative terminal, this is the positive terminal. Again this is the positive terminal that should connect it to the negative terminal of the cell. Again positive terminal should connect it to the negative terminal of the cell. Or we can draw in opposite way also. This is a cell. Now just a reverse condition I am connecting. Now reverse condition. Here you can see that same cells only, but one after other I connected, but reverse condition. Here it's a positive terminal you can see, but here negative terminal. Here positive terminal, here negative terminal. Similarly here negative terminal, positive terminal, negative terminal, positive terminal. Now current flow from positive terminal to the negative terminal, and from the positive terminal to the negative terminal, and from positive terminal to the negative terminal. Now from this positive terminal to the appliance, here now from the negative terminal to the appliance. Any device, its a connection will be there. So here now this is the negative one, so here I am writing negative terminal. Now this is now positive, then here this is a positive terminal. Now any of the device we can connect to this. Then here number of cells are more, as a result of it more potential difference will produce. If more potential difference will be there, then more current will produce. So in which all devices, depending upon the devices we can say, or depending upon the vehicles, if small vehicle is there, so number of cells we have to use less. At the same time large vehicles will be there, then the number of cells connection will be more. How much cells more we are using, that much potential difference will produce. As a result of it, current production more. As a result of it, more and more bulbs can be able to work. Now similarly here also, now the connection here, this negative terminal we have to connect it to the device. Again here this positive terminal we have to connect it to the device. So this is the positive terminal, so here it will be positive. Now from this negative terminal I connected the wire, and this is connecting to the device. So we can say that here again the device will be there. Any device, any vehicle we can say, any device, or mobile, or we can say that if you are using laptop, etc. Any of the instrument we are connecting with that, depending upon the number of cells connection, or we can say depending upon the number of electrodes connection, the current production will be more. More electrodes if you are connecting, or more cells if you are connecting, more potential difference will produce. If more potential difference, then there will be the production of more and more current. Thank you.